Heyo, it's Mr. Otwell, the Math Master, helping you master math. And today we're going to be talking about radical expressions. Pretty radical, right? I'm excited. So, the first thing we want to jump into is how are we going to even talk about the different pieces of our radical expression? Because if we don't know what those words are and what they mean, it really makes looking at our properties a little harder. So, let's start at the beginning. I feel like many of you, some of you might be familiar with what we call this symbol right here. This symbol right here, this lovely beauty is called the radical. All right, this is what we call the radical. This little branchy guy kind of looks like the division symbol, but it's got this little bitty guy right here on the end. Next, we have all this stuff underneath the radical. Any term, anything that is underneath the radical, inside the radical, we call this the radicand. Not the radicant, the radicand. Right? Right? Exactly. And last but not least, we have the index. The index is just going to be a little number here on top of our radical, just sitting right on top of this little bitty branch right there. So if we see some sort of radical expression, how do we talk about it? What do we say? We would say the b root of x. For example, if we're going to go with just numbers, something we would normally see, if you have the radical here, we have the 8 in the radicand and our 3 as our index, we would say the third root of 8, okay? And you need to realize the radical is asking you to do something. It is an operation, very similar to addition, subtraction, multiplication. They're telling you to do something. This is the same as the radical, okay? It's telling you to do something. But what does it want you to do? This is what it's telling you to do. It's asking you what number multiplied by itself b times gets you x. Okay, so for example, if we wanted to look at what is the third root of 8, the third root of 8, we would ask ourselves, well, what number, if we multiply it times itself 3 times the number of the index, will get us 8? Well, that number will be 2, because think about it. We got 2 times 2 times 2, that is 8. Okay, another way to write 2 times 2 times 2 is 2 to the third power. And we'll come back to why this exponential form is so important later when we talk about simplifying it. But we really need to key in on this idea. We know that 2 times itself 3 times gets us 8. Therefore, the cubed root of 8, or the third root of 8, is equal to 2. So now let's take a look at some of the common properties of radicals that we deal with. For example, if we had the b root of x times y, that's going to be the same thing as the b root of x times the b root of y. Really what's happening here is I want you to notice that b, our index, is staying the exact same on both sides of the equation, okay? Also, notice these are multiplied together, not adding. These are multiplied, not adding. So if you are multiplying things, if you have factors underneath your radical, you can actually split those factors up into 2 separate roots and have their own little radical. This property is going to come in very handy when we start simplifying radical expressions. But just for now, let's look at an example. Let's say we had the third root of 5 times 4. We have 2 factors here, 5 and 4, and they're under the radical. 5 and 4 are factors, and they are the radicand. This would be the same as the third root of 5 times the third root of 4. So notice our index stayed the same, and we were able to split our factors 5 and 4 into separate radicals. Our next property is very similar. If you have a fraction under a radical, you can actually split that fraction up and put both the numerator and the denominator in their own separate radical. So for example, if we had the square root of 3 over 10, that's the same as the square root of 3 divided by the square root of 10. Now you might be asking, Mr. Otwell, you said square root, but there's no little number right here. How did you know that was the square root? Well, let me tell you something that I will tell you many times. Mathematicians, we're just lazy, man. We don't want to write more than we actually have to. So because the most common radical we use is the square root, you've probably seen it before. you may have asked yourself, hey, you were saying this is a radical. I've just heard that was a square root. Are you sure this is called a radical, Mr. Oswald? Do you really know what you're talking about? Yes, it's just we're lazy. We're mathematicians and we're lazy. If we do not write an index, it's just understood that that index is a 2. Okay? So if there is no index, it's not there, then we know that that's actually just the square root. Okay? The index is a 2. We just don't write it. And the last property we'll talk about is how we can take a radical expression and represent it as a rational exponent. Rational just means fraction. So if we have a radical expression, we can represent it as some base to the power of some fraction. Okay. Now notice, where is this a ending up in this side of the equation? Where is this b ending up on this side of the equation? Where is this x coming from? Here. If you're able to just see that this x right here, this x right here stays the base, okay? The base of x will stay the same as the base of x. And notice the exponent of what's inside the radical will become the numerator of your fraction, and your index will become the denominator of your exponent. So for example, if we had the square root of x to the 9th power, remember, we're lazy. If there's no index there, what is it? It's a 2. You're right. So we know there's a 2 here. Let's just go ahead and write it just for the sake of this example. We usually don't write it though. If we have x to the 9th power underneath the radical and we have an index of a 2, remember, our bases, they're going to stay the same. So what's the base of the radicand? X. So we're just going to write x. Then the exponent of our radicand will become the numerator of our new exponent. So we're going to put that on the top, and then the index becomes our denominator. So here are the main things we want to be remembering when we're talking about radical expressions. What are radical expressions? They have radicals in them. That's what they are. What's inside the radical is called the radicand. This little guy up here on top of the little branch, that's called the index. Remember, radicals are telling you to do something. It's an operation. It's saying what number times itself, whatever the index is, gets you the radicand. These are the most common properties we'll be using when we're simplifying radical expressions. Ultimately, this is where we're going. We're going to be simplifying rational expressions. If we have factors underneath the radical, we can split those factors up into 2 separate radicals. If we have a fraction under the radical, we can split the numerator of the fraction, give it its own radical, split the denominator of the fraction, give it its own radical. And then if we need to, sometimes this just makes our life easier, we can represent a radical expression as a rational exponent. I hope that now you get a little better feel of what radical expressions are and some common properties we'll be using so that we can actually simplify radical expressions. Please make sure to subscribe, like, and comment. Turn those notifications on so that I can see you in the next video.